For example 4, it says find the number of terms in this sequence where it's starting at 4,374 and making its way down to 2. Well, I know my term 1 is equal to 4,374, and my ratio is going to be 1,458 divided by 4,374, which can reduce down to 1 over 3. I'm going to state that my final term, 2, is equal to 4,374 times 1/3 of n minus 1. If I divide both sides by 4,374, then I'm going to get a reduced fraction, 1 over 2,187 is equal to 1/3 of n minus 1. And I'm going to use my logs trick to solve for what n minus 1 is again. I'm going to say that my exponent, n minus 1, is going to equal log of 1 divided by 2,187 divided by log of 1 over 3, which is going to give me 7. So if n minus 1 is equal to 7, then n is equal to 8. There are 8 terms in this sequence. For example 5, in a geometric sequence, if term 5 is 405 and term 8 is 10,935, then the first thing I'm going to do is I'm going to solve my ratio. My ratio is going to equal, well, I have 8 minus 5 terms, and that's going to be my index of that 10935 divided by 405. Or 8 minus 5 is going to be 3, and 10,935 divided by 405 is going to be 27. I'm multiplying by 3 every single time. If 405 is equal to term 1 times 3 to the power of 5 minus 1, then term 1 is going to equal 405 divided by 3 to the power of 5 minus 1, or 4, which is going to give me a term 1 value of 5. I can state that for my general form, Tn is going to equal 5 times 3 to the power of n minus 1. If I'm listing the first 4 terms in the sequence, well, the first term is 5. Then if I multiply that by 3, I'm going to get 15, then 45, then 135. And if I multiply by 3 again, I'll get that fifth term of 405. I'm going to graph out this sequence and say that I'm starting at 0. This is going to be my Tn, and this is going to be my n value. I can see that I get up to 135 here, which means that I'm going to make every line worth 10, or every second line 20. And I can say that every third line is going to be 1. I start out with my first term being 5, then my second term is 15, then I go up to 435, and then I'm going to go up to 135. Does this graph appear to be linear or nonlinear? It is definitely nonlinear. If I'm taking a look at the application, the population of Mathville increases by 4% each year for the next 10 years. If the initial population is 100,000 people, what will the population be in 10 years? Well, I know that my term 1 is going to equal 100,000. My ratio is going to be an increase of 4%. So I'm going to take my 1 that I originally had and then add another 4%, which means I'm multiplying by 1.04 every single time. I'm keeping what I had and then doing an extra 4% on top of that. In 10 years means that there's going to be 10 changes. So if n minus 1, the number of changes, is going to be 10, then in 10 years, I'm actually looking for term 11, because in term 1, no time has actually taken place. Be careful about this when you're doing any of these solving dates or that problems. So, I'm going to put in my information. In 10 years is going to be term 11. It's going to be 100,000 times 1.04 to the power of 11 minus 1, or 10 changes. Term 11 is going to equal 148024. In 10 years, the population will be about 482,024 people.